Welcome to LabMinutes.com. As you know, not all network devices are capable of 802.1x. Now, to get them on the network, you can disable .1x on the port the device is connected to, but at the same time running a risk of unauthorized user coming along and connect to that port. A good example of this is an IP phone in the public area. To prevent that, you can enable .1x on those ports, but that means we need to find a way to identify and authenticate these devices. The simplest way is to manually create a list of allowed MAC addresses, so any devices with the MAC address on the list will be allowed on the network, while the access privilege is determined by the group of the device belongs to. This is known as MAC address bypass, or MAP. Alternatively, Cisco ISE provides a more sophisticated method to automatically determine the types of device through a series of probes, and then you can come up with an authorization policies to grant appropriate level of access accordingly. This is known as profiling. So in this video, we will look at how we can use Cisco ISE profiling, probing, and MAC address bypass together to support devices that are incapable of providing lock-in credential. So here's our lab setup. So we have an ISE server running version 1.1.2 at the IP of .102, and then we have a switch that we have enabled 802.1x on. So we will be dealing with three type of devices. One is access point that we're trying to profile, and we will be pushing a downloadable ACL or DACL. So all access that it will have is to access or communicate with the wireless LAN controller. We will have a phone plugged into the network, and once it's being profiled as the Cisco phone, it will have all the network access or permit IP any. At the same time, we will demonstrate an example of a MAC address bypass. So we're going to have a PC that we will assume it's an unknown or unsupported OS. So we will try to configure a static MAC address, and based on that, it will authenticate through MAP and get a network access. So we're just going to use a PC, but with have an 802.1x disabled. Okay, so the switch port that we'll be dealing with is 14, 15, and 19. And just to show you the config, all these ports has been pre-configured to run 802.1x. So let's start off with 14. And other devices will be placed on VLAN 64 that has been enabled for DSCP as well. So here's the configuration for port 14, VLAN 64. Here's the configuration that we have gone through in our previous video on the recommended switch configuration. Now for 15, it's for IP phone. So we have a command switchboard voice VLAN 64 to make sure the phone is placed on the VLAN 64, and then 19 also, and this one is for a PC that we have. Okay, so the first thing we're going to go through is the probings. So ISE comes by default with a set of probes that you can utilize as part of profiling. So you go administration, deployment. Okay, so we have a node as a standalone mode. Click on that. And here, since it's a standalone mode, it has all the personas, including the policy service, and by default, the profiling is enabled. Okay, so profiling is performed if you happens to have a distributed deployment. The profiling is performed by your policy service nodes. Okay, now we go to the next tab, which is profiling configuration, which for the most part we have them enabled in our previous video. Let's go through them one by one. So let's start off with NetFlow. So if you guys are familiar with NetFlow, NetFlow collects the traffic or flows information from whether it's a switch or a router. So switch, if it supports NetFlows, then we'll be able to provide that information. And as part of that, ISE can use it somewhat to determine what kind of flows a device is generating. Although there's a very little use as far as the profiling is concerned, and when you enable NetFlow, there's potential that it will end up with a high volume of traffic that can impact the performance on ISE. Okay, but for now, we're just going to enable it, although we won't be using it. Next will be, is a DSCP. So the idea for DSCP is for the DSCP packets to be sent, or a copy of the packet actually to be sent to ISE, so ISE can kind of glean inside the packet and gather the information, and this is usually done by the help of the IP helper address that you configure on the switch, which we do have here. Since we are using VLAN 64, you can see here we have a helper address that points towards ISE. And obviously, if you have a separate DSCP server that you use, then you will have another helper address that points to that. Just because ISE receives a DSCP packet doesn't mean it has to reply or assign IPs. It just needs to look inside those packets to get the information for profiling. DSCP span is very similar. The concept is the same. It's for ISE to receive the DSCP, but in case you cannot do a helper address, the other way is to do a packet mirror or a spanning sessions from a switch to ISE. So you can configure additional interface to show you here for ISE to a dedicated interface for ISE to receive the span traffic, which we are not doing in our lab. Now, HTTP. So if you ever sniff out HTTP packet, you will see that in the header, there's a lot of information that will reveal basically what kind of client it is, browser type, there's OS the client's running as part of the user agent attributes. So ISE can basically use this information as well as far as the profiling. Now, to get the HTTP packet to ISE, there's usually two ways of doing it. One is URL redirect, which we will look at in a future lab, and that's going to happen when you have a web login. So the client or the user open a web browser, gets redirected to ISE, so ISE will be seeing the HTTP packet. The other way is to do, again, spanning session. Again, you have to make sure that you span the right place so ISE can see all those HTTP traffic that's coming from the client. So here we have that enabled. Now, radius, since for the most part when we're doing authentication, we'll be using radius. ISE can look inside radius attributes when it's received like radius attributes, whether it's from as part of the authentication or even accounting. So ISE can get a lot of information from the radius accounting as well, and use that as part of profiling. And we have that enabled. Network scan. There's two types of network scan that ISE can perform, and it's considered an active probe. Other type of probes that we have here, it's considered passive as far as it's the one that just sits quietly and receives the information. But for a network scan, ISE actually has to go out and do a scan on whether it's on the network scan or a device scan to get more information on a particular device. And you can see right here, you can specify a subnet and manually run a scan. Okay, and we have that disabled right now. So let's go ahead and enable that. Okay, DNS. So ISE use DNS to figure out FQDN of the endpoint, assuming the DNS server has the reverse lookup. So ISE can basically map the IP to the name of the endpoint. Okay, SNMP query. So ISE is capable of going out and do a SNMP query on a switch and access certain MIPS to gather information that a switch has, whether it's a CDP or interface status or even app table, and kind of compile it and use that to profile a device or even device discovery. SNMP trap, on the other hand, relies on a network access device to send an SNMP trap when there's a change or an event that happens, and it's usually a real-time information, and this could be, for example, change in link status or MAC address changes. You can see here there's a link trap query, there's a MAC trap query. So you probably want to have that enabled as well. But actually, let me go back to radius. I just want to show you the configuration that we have for radius on the switch. So look for the AAA command and radius command. So for the AAA, you got authentication accounting turn on, and then for radius, you got a bunch of attributes, accounting authentication turn on, and that will be sent to ISE. Okay, the other probe that we talked about was SNMP, so we can look at the SNMP configuration in the switch. You guys can see SNMP trap for MAC notification, remove and add is enable. Source from loopback 0, community, this is for SNMP query. And for the trap, we have ISE as the SNMP server configured with MAC notification. So again, all these configuration has been, we've gone through that in the previous video on the recommended switch and wireless LAN controller configuration. So if you guys want to go back and take a look at that, just to understand this configuration. All right, so now we've gone through all the probes that ISE is capable of. Now let's take a look before we actually start on the authentication as far as what we have so far. And actually one of the most useful probes is the SNMP query. As you can see here, we have access list 10 that ties to that, so we kind of lock it down to the access list, to the ISE server to be able to do an SNMP query on the switch. You can see there's some matches already, so ISE has been querying the switch for information. So let's see what kind of information ISE has gotten so far. And here if you go to administration, identity, and at the endpoint, here's the list of endpoints. Although we haven't really configured anything specifically to the endpoint, ISE is able to discover those endpoints just through all those probes. And let's pick one. For example, we have an access point plugged in, status unauthenticated. Here's the calling station MAC address, for example. And you can see the source came from Radius probe because we have those .1x turned on and it's been trying to authenticate. You got MAC address again. Just want to see what's we might find that useful. So you can see there's a lot of information that I has gotten from the switch. And here is the bunch of CDP attributes, and right here where it says it's what kind of access point it is, even the software it's running. Okay, so let's go back. Let's pick phone. We also have a phone. Again, not authenticated so far since we've yet to configure the policy. Information came from the Radius probe. Okay, we got identity group because ISE came by default with a Cisco IP phone identity group configured, so it's been placed under that group. Again, here's just an example of what kind of information ISE has gathered from those probes. Okay, so now let's take a look at how the device actually get profile. So if you go to policies, condition, and profiling, and if you scroll down, there's it's pretty extensive list of checks that ISE perform. So let's pick an example since we're dealing with things like access points. So let's see, we have a Cisco access point right here, and we are 1130 is what we're using. Okay, so an example of a check here is basically if there's a match in the DSCP equal, I guess SDP must contain some kind of attributes that indicates an access point. So that's one of the check that ISE will perform just to see what kind of device it is. So you can see there's a lot of checks that ISE can do. And now based on the results of these checks, ISE will compile that information and if you go to policy and profiling, and you actually see the default policies that comes by default with ISE, and under those policies, again, let's take a look at our access point 1130. The policies, profiling policies is nothing but a group of checks that ISE perform, and if the check is successful, it will give a what they call a certainty factor score for each checks. And once that number has exceeded the minimum certainty factors, then ISE determine what kind of device it is. Okay, so that's how ISE figure out or actually profile the device. Let's see what else is let's pick another one to look at. Let's say Apple iPhones. Okay, so let's see what it takes for ISE to determine or decide if a device is an Apple iPhone. So obviously it has to pass at least one of this check, because each of these has the factor of 20, and the minimum factor is, or the certainty factor is 20. Okay, so once ISE has determined the type of device, now we need to figure out how to use that information as part of our authentication authorization. So you see by default, we show you, and that's by default under groups, and then there's Endpoint Identity Groups. By default, ISE has already created a group for you. One is for Cisco IP phone. If you click enter that, you can see there's already a MAC address there, which is, I believe, is the phone that we plugged into the network. And there's also a by default group of workstations. So now we somehow have to convert those profile policies into a group. So let's say, so in this lab, since we're dealing with IP phone, access point, and in the future lab we might have to deal with Windows and iPhone. So let's go ahead and create those groups. And the way to do that, you go back to policy and profiling, okay, and then you locate the policies of the device that you want to include or want to use. So let's say we want to do Apple iPhone, and right here by default Apple iPhone is a subcategory or subgroup under Apple device, since it's also considered as an Apple device. But if you want to create a more specific group to Apple iPhone, then what you have to do, instead of use the hierarchy, we go and create its own identity group. Okay. By the way, I did not mention the network scan option here, so we can also configure ISE to perform certain type of scans if ISE feels that there's not enough information to determine the device type. So here you have an option for ISE to go and scan, for example, a particular device and then determine if it's actually an Apple iPhone or not. Okay, so now we're going to create a identity group for the iPhone. Click Save. We're going to do a couple more. One is that we're going to do is Windows 7. Before that, if you go down the list, let's do access point first. So let's just do access point in general instead of a specific model. Again, access point is part of the parent policy of Cisco device, but we want a separate group for that. Save. Okay, now we want to Windows 7. So let's see if we can find that. Okay, Windows 7 workstation right here. Click. Again, it's under a parent policy of Microsoft Workstation, but we want its own group. So save. Now if we go back to group, let's open a new tab. Okay, if you expand the profile one more time, now we have, in addition to the IP phone and workstation, we now also have Apple iPhone, access point, and Windows 7. The next question is, what if device is not supported by ISE? Which means whatever device, the network device that you have, might not be included in the profiling policies. Okay, well, so there are actually two ways to tackle that. One is to create your own check. So if you go back to policies, conditions, profiling, right here, checks, you can add a check, but given only that you know exactly what the attributes for that device looks like. So you can create a match for that. And based on this, if you have that information, you create a number of checks and then come up with your own profiling policies. But that's going to require you to know what attributes to look for in each of the specific probes. Okay. Second option is to, which is what we're going to look at in this lab, is to create a static MAC address of the device, and you can come up with your own identity group. So let's actually go ahead and do that. In our lab, we say we're going to have a PC with, let's say, an OS that's not known by ISE. So we're just going to say, okay, if the MAC address match the one that we configured, we're going to group it to, let's go ahead and create a group. The word right here, Endpoint Identity Group. And let's call it LM Unknown OS. Parents, we don't really need a parent, so we'll go submit. So now we have it right there. Next, we're going to statically add the MAC address. That's going to be under identities. And the MAC address of the PC, let's go back to the switch and take a look at I believe it's this one right here. So copy. Go to identities, endpoints, and we go add. Actually, the device might have been, or MAC address might have been discovered by ISE already. So it ends with 65, let's see, 6F5D. Okay, all right, there you go, right here. It's so far ISE say it's a VMware type of device, but let's say we want to, for policy assignment, let's do unknown, and we want that to be static assignments, and for group assignments, we want it to be LM Unknown OS. Actually, let's go back and leave it at VM. Let's try that one more time. Just leave that alone. But for the group, you want to statically assign it to a group called LM Unknown OS. Okay, and you can see it was discovered by SNMP query probed. Okay, so save.